All right, so for today's demonstration, I'm going to kind of go back through and rehash several things that we've talked about, but I have also built a application here, a simple application that we're going to review and run through with you guys. So in our application, we have two limit switch sensors. I have two solenoids that will fill a tank, and then I have an emptying valve. So for my tank, I have solenoid 1, so I have certain conditions. So I have and conditions that solenoid will have, and then conditions when it's off. Same thing for the other individual ones. But the last thing here that I developed was just a normal sequence of operations. So solenoid turns on until sensor 1 is on, solenoid turns off, the first solenoid, then the second solenoid will turn on until sensor 2 is turned on. Once sensor 2 gets hit, solenoid 2 turns off, the motor will turn on, mix the two solutions together. It will stay mixing until the third solenoid turns on. So after 10 seconds, is which I have, the motor will turn off and turn on solenoid 3. So we have this delay in here so we're going to mix for a configurable time. And then again, we will empty. So really we will empty the tank 30 seconds after sensor 1 turns off. So there's some sort of delay holding solenoid 3 open to ensure that everything is executed. And then the last thing is the system must remain in auto in the event that everything is changed to manual. All the equipment will return to its initial safe state. So I'm going to kind of go back onto this screen here just to show you just a review again real quick, so you can, now that we went through the operation, so you can kind of see your two sensors. We added this extra time delay just to get this extra material out of there. I just wanted to cover that. And then, so at this point, what we're going to do is we're going to switch over and go to my virtual machine. One of the first topics we covered today was ControlFLASH Plus, and I want to show you what that looks like. So for today, we are not going to flash everything, just because when you do flash, you have to keep in mind it takes approximately 15 minutes ballpark to flash a controller or a panel view, and both of those are the ones we're working with today. Let's see. So we're going to change. So inside here, so you have what devices do you want to flash? But I know that I don't have those. So what I want to do is I want to open this up there. So now, so today we are hooked up to a 5069 L340 ERM. So just to fill you in, the ER, so E means Ethernet, R means redundant, so you can do DLR. M means motion, and then if you have safety, you would have an S also. With the new controllers, you don't have to have all of them. So you can have an ERS, you can have an ERM, you can have an ERMS, so you can have multiple. And then we have a panel view that I'm also hooked up to today. But what I need to do is we're going to now use this driver, and we're going to click OK. And what it's doing now is it's checking what do those devices have. In my device, I have 32012. Let's see if there's a new one out. There is actually a new one out. So as you can see here, if there's a little down arrow, it means I do not have that installed on my computer, but it would need to be downloaded off of the website. Same thing for here. So if I wanted to I don't have any firmware installed for the panel view. What you need to do is you can see here in this bottom left, I have a little yellow and it says download center is available. So it'll be red if you do not have a network connection or it cannot see the internet for some reason. It is yellow, letting you know that it's there, but you need to sign in. If I click the sign in button, it will open up a browser for me, a login, and then it'll say, okay, you are connected and authorized to download this stuff off of Rockwell. And that is a free, right? So download firmware, it's free. It doesn't need anything, but you have to have an account assigned to you. And then your little download center will turn green and it'll say download center connected. That's when you could select these. You can check the boxes. So if I wanted to do both, or you want to do just one, you can hit next, which we're not going to do. It's going to say warning. You're going to flash and change this device. If it has an SD card and it's locked, it's also going to cause a problem. So you have to keep that in mind. And then you just hit flash. So it's that simple. It's a very good software. The previous software, you had to download everything, register to your computer, and then open up a separate platform. It was far more complicated, whereas the new one, it just uses your network browser, finds everything for you. It's pretty nice, pretty simple. If you wanted to, right? So here, this shows all the software or all the firmware I actually have installed, plus the life cycle of it. If I wanted to find that, and then favorites, I don't really have a favorite because I just work on everything. So I'm gonna hit cancel so we don't have to do any of this because I don't really want to flash. All right, so the next thing we're gonna do is I'm gonna open Studio 5000. So I have already created a project that we're gonna be working off of, but I did want to show you creating a new project with Studio 5000. So if you hit new project, so Studio 5000 now has the ability to launch FactoryTalk View Studio for you here. You have Logix Designer, which is your controllers, which is what we're working with today. And then you have View Designer, which is the new PanelView 5000 series, so the 5310 and 5510. But for today, just for kicks and giggles, we're just going to make a L306 compact Logix, and this is just going to be test. Throw it on my desktop, that's fine with me. I'm gonna hit next. So it's gonna ask what revision. So I only have version 32 installed on this virtual machine. My other virtual machine has everything else. Again, if you wanted to add protection, most people don't add security authentication here. That is a different style of security as opposed to what they call OEM lock or something like that, where you want to lock individual snippets of code. So this locks the entire control. That will lock the entire controller, period. Can't even connect to it without security. The other one would allow you to connect to it to monitor, but no one could copy and paste or steal or edit your logic that you created if you wanted to protect that. While that's loading, I'm actually going to load our other program that we're going to be working with. Okay, so here again is the actual setup. So you have your controller here. So you see how there is no defined chassis size. So you can add modules as you choose. Right now, the controller is set up to have two separate IP addresses. So there are two ports. You have two separate IP addresses. So to get to the controller properties, you can double click here on the controller. You can double click the controller up top again. So you see how it says controller and test, because that is the name of the controller. And then the other spot was here. You can check IO forcing and also the controller properties. So there's a couple different places. But for the two IP addresses you have here, so you have dual IP. Dual IP allows you to have independent ones. The other option would be linear or DLR, so device level ring. What that's going to do is that actually, if you plug into a single port, you can go back out the other one, and it mirrors each other so that you don't have to have separate IP addresses. All right, so I just wanted to kind of show you guys what a new program would look, or a new project would look like. And again, by default, it's always going to create a main task, a main program, and a main routine. The task by default is continuous. With version 33, they're going to change that the default is actually going to be periodic. And I'm sorry, it was actually 10 milliseconds is the default. I said 100 earlier. So we're going to change apply, okay. Then you have your main program. And again, by default, that main routine is selected. So we're going to go here. So scheduled in main. Under your configuration, here you go. So assigned routines, you have to have a main routine. You do not need a fault routine. I wouldn't worry about that. But if this is set to none, let's click apply. Okay. The one goes away on main routine, and now no logic inside this program will execute. So again, that's if you're copying and pasting things like that from a different one, it will put that to none. So you have to remember to come back in and create it. So by default, the controller knows to do this for you. But if you are copying and pasting, it will not do it. So you need to make sure you add that connection. Let's see if our other, yeah, so our other one is open now. So we're going to close this. I don't care to save it right now. Okay, so I created a different program in which I called the program the Studio 5000 Basic class, which is what we have today. So I wanted to show you everything that we have. So I have a L340 ERM, which I showed you in the ControlFLASH Plus program. And you can see I have a few local cards. So I have card 1, card 2, card 3, or 4, I'm sorry. So there is actually a card in slot 3. If you do not want to use the card, you don't have to configure it, but it will flash, not a fault, but it will just flash for you on the actual hardware, letting you know that it is not configured and does not have a master. So a owner or master, either one, nothing is looking for that IO. So if you wired something to it, doesn't matter. The IO will execute, right? Like it's physically powered, it's there, but nobody owns it, nobody's monitoring that IO, and that's how the card lets you know. It just flashes a green light to let you know that it's there, but it's just not configured or not being controlled. I also have a remote rack, which I actually have an older style, so the 1769 Compact Logics, that has a few cards on it. But as you can see, there's this yellow circle. So the yellow circle, I'm going to get to this, I'm going to double click and open the configuration. So this is the module properties, and right here, so you have this connection, you can inhibit module. It immediately puts the status to offline and puts a pause button. That's what that is. If you uninhibit it, and I don't have it plugged in right now to that, you will get a status of faulted, and it's very tricky, and I wish they changed it, but it's a yellow triangle. So the yellow pause button is okay, the yellow triangle is not okay. So when you in the event you see IO that drops, you want to double check and get a magnifying glass, whatever it requires, but you need to double check to make sure that it's not faulted or that it's not a triangle. So I'm not gonna change the configuration, I'm gonna leave that set up like that. So what we're gonna do for the first thing is that we're gonna go online. So I'm going to hit that start button and then go online. The other thing you could do would come up here to our path and do it this way, which is the traditional way of doing it. But we're going to hit online and we're going to see if something's different. Okay, so I made changes before we started the class today. So this is the prompt to let you know that something is different. So you can look and see, okay, the controller's the same, path is okay. The serial number is the same, but it just says that the open project has offline changes that aren't in the controller. So you have your options here. Again, you can upload or download. So what I'm going to do is I know I made the changes, so I'm going to download and I'm going to override what I have in the controller. If you didn't know, especially with the newer platforms, so 21 and above store all the information on the controller, I would definitely hit upload. You will maintain all the comments and everything else. So we're going to hit download. It's going to give you a prompt. This is notifying you that it's going to put the controller into remote run. So I'm in remote already, which is the only reason I can't download. It's going to be changed and everything else is all going to stop. So just verify that everything is okay before you do this. We're going to hit download. So now download is done. This is that prompt where you can hit yes or no to put it back. So for now, I'm just going to hit no. I'm going to show you. So it stays blue and it lets you know it's in program. And this is where you can put it back into run mode. On the download, you can also change it. Also, you'll see your little indicator here kind of changes. You don't really have to get used to that. I would just look here just to see. Okay, so here's your status of your controller. My IO is okay. Even though I skipped that third one, it's no problem. It's just sitting there. Controller is okay, and we are in run mode. All right, so now that we've downloaded, you can see, and the reason I inhibited just the main module here is so you could see the difference between them. So you have a yellow pause button, and this is an exclamation point that's a yellow triangle. Again, I know it's a little bit difficult to see, but you want to notice that there is a difference. And if you see that the yellow triangle, it means that there is nothing there, that the controller is going to have a problem. So since I inhibited the parent of the I/O, it will not fault the controller. So even if the I/O goes missing, if the parent is, I'm not telling it to look for the parent, then it doesn't care that the rest of the I/O is gone. So that's just a quick thing that we want to see. So the other one I wanted to show you guys, so now that we're online, you can go to the back plane, you can right click, you can do new module, which would be a manual entry on your own, or you can hit discover modules. I just want to show you that it actually works now for anybody who's ever seen any of the other ones. All right, so there you can see that I had these two set up already, but this one was not created, and that's why you have a create button. If you wanted to get back and do it manually, you can still do it this way. So like, so ours was a 5069 dash, what I have an IY4. So there it would show it there, or you can come back to the discover, give it a few seconds. What it's doing is it's just panning its background, but it automatically puts it in the proper location and a couple of little things. So it's nice to do the module discovery. So we can hit create. So it will pull, so if you do discover, it will automatically pull the series and revision for you. If you do it manually, you will have to select the series. Sorry, you'll have to select the series and the revision. So for this one, this is just my local, this is an analog input, and this is just my first card. My first analog input card, at least. It knows that it's in slot 3 because I did the module discovery. Again, here's this stuff. I'm going to leave it as compatible module for outside stuff. If you hit change, you can still change this if you wanted, but by default, doing the discover automatically gets you everything you want. So as you can see that the tabs changed for version 32 also a little bit, or the newer hardware. So the newer hardware, the 5069, has a browser pane over here as opposed to the tabs, which the 1769 and 1756 have the tabs that I was showing you throughout the rest of the presentation. So here again, but the content is still identical. Module info. I don't have anything hooked up to this, so just to keep it from faulting, I'm going to disable everything. So you have, there's my 4 individual channels. So each of the individual channels can have their own configuration. And then there's also the CJ channels. So this is so I'll bring this back. So we'll undo this. So I have an IY4. So it does voltage, current, RTD, and thermocouple, which is why you have to have the CJ. So I'm just going to leave it back at this. We'll put it back to disabled, but I just want to make sure I disable everything for it. Otherwise, it will fault my controller because it's looking for something to be landed there on the CJ, and it's not. And then there's the calibration. So if you're at a company that has calibration, you can add calibration to this and it can verify it for you. Most of the time, people are not going to have to worry about that. All right, but we think everything's okay. Click OK. And it says this is going to make an online module creation. You can inhibit it just in case you're not 100% sure that you did everything right. You can inhibit it, which would prevent the controller from faulting. Since we did module discovery, I feel pretty confident we did it right. We'll just hit yes. So now my discovery here says everything is there. Hit cancel, it's all here. And I have no IO fault. So this would turn red. If the configuration for this was wrong, it would turn red and stop the controller. The other little thing we're going to do today is, so I have this IO task. I left my IO task as continuous just to show you, but I'm going to add, and you can add a new program, but I'm going to import a program. And I just want to show you. So this is what I made the change earlier. I just wanted to show. So if you export and import, I'm going to hit create. It has the ability to create all the tags for you. Right? So that's one of the major reasons that you would like, that it's best to export and import. And you can export and import routines, add-on instructions, and you can export and import full programs. And as you can see, I have add-on instructions that are a part of this. I have an AI standard and an AO standard that I've built. Then inside my routines, I have a couple of tags that I created. It has everything. If you copy and paste, you will have to manually do all that on your own. And then if you really wanted, you can change where it's going to get implemented, but I want it to stay inside my IO task. So I think everything will be okay. We'll click OK. So you can import everything as pending. So if you're not 100% sure and you want to go through and check it, you can. You can accept the program edits, which will put it into a test mode, or you can finalize, which would mean just put everything in there and I know it's okay. And that's what we're going to do right now. So now you can see that I have an IO program. Open up my IO program. I have my digital inputs and outputs, but really what comes in is this IO main. So right now we have jump to subroutines. I just jumped based on the order that I had, but in the event that I want to check my digital before I check my analog, you can move this. So you can take this, drag it up to the top, and it makes, so you see how you see D. So this is still running. So you see how the brake's not there, or you can bring it up to the front. So then here, you have finalize edits. You have an accept pending. So accept pending. So what this is doing is this is checking to make sure you don't have any errors. So, okay, it accepted and took it. So now you have to test everything. And again, you can back out and cancel if you want. If you're like, oh no, I'm still not done. But you can hit test. So at this point, it will put this into the program, but it's in a hybrid at this point. So you can see that my power flow shifted off of those and up here, but I still have these couple of editors on the side. So I's is in pending edit and D is deletes. Finalize will store it permanently to memory. If you have a pending, you can untest and cancel and back out and get to what you had. So if you weren't sure that what you were going to do works, you can do this by testing and then, oh, it didn't work, quickly hit the cancel here, as opposed to finalizing, which will download, so to speak, or store these changes inside the controller. But I'm going to go ahead and finalize and put it in. And now, based on execution, I will check my digital inputs, then analog inputs, then analog out, then digital out, because it will execute down the line. We're going to toggle this and we're going to put it in webinar mode for our rest of our situation here. But primarily, we're going to be going back and we're going to be dealing in this main task, main program, main routine. All right. So now we are in that logic that I said we were going to create. So I went through and I have some IO. So my very first thing that I do is I go and check that IO. So before executing any of my program, it will actually jump down and come to here. I'm going to open up, and I did this in structured text just to show you guys so you can see this. So by default, it will not show you the live values. What you have to do is hit this little button right here. So it looks like glasses, but it's inline values. So now you can see what is actually happening. All right, so our first rung is going and checking this webinar. So for structured text, a lot of people aren't familiar with the syntax. What I would recommend is if you're in the structured text, just pick a tag and then hit F1. All right, so if pressing F1 will open up the editor. What I always look for, and look, there's got a couple of recent searches. Type in syntax, structured text syntax. So this is where you want to go to understand how to do the expressions. And if you have an error, this will explain what the error could be and where it would be, because 9 times out of 10, it's going to be a syntax error. So you always have to have the semicolon at the end to terminate a expression. If you are assigning a value, right, assignment, you always have to have colon equal to. It's not just equal to, because that is an operator expression. So it's different. So you can have equal, equal, greater than equal to, things like that. So there are different ways of doing things. So the syntax is actually a really good way to quickly test it. And all you do, again, you go to this, hit F1, and then just type in the word syntax in the search bar, and it's the very first one. So if you ever want to figure out how to use the structured text editor, that's where you'd want to go. But for the rest of today, we're going to be dealing with our ladder logic. Okay, so what I did is I went through and I created a mode switch, right? So inside our sequence of operation, and we said that the system must remain in auto for the sequence to operate. So for every condition, I have to be in auto. So auto equals 1. If my auto does not equal 1, so if I'm in 0 for mode switch, then I turn off all my outputs, because that's where my safe state is. Motor's not running, valves are all closed. The inputs don't matter, right? Because they just read, so it's just shutting off all my outputs. So skipping that, the next thing we had, right? So sensor 1 will turn on until, or I'm sorry, solenoid 1 will turn on until sensor 1 turns on. So I have, as long as solenoid 3 is not on, the motor is not on, and sensor 1 is not on, then we will turn on input 1. So we're going to do that now. So the next thing we did, so again, this is an AND statement, so we just have those. The next thing I did here, so we are filling until the input 1 turns on. So when input 1 will turn on, which means we've made it, it turns on, we will turn off that input, and we will fill from solenoid number 2 until sensor 2 turns on. So I have an OR statement shutting off input 2. I didn't need to do it that way, but I just wanted to show you, you can build self latches to do this, or you can do a latch and unlatch coil. I just did that intentionally so that I could show you how to use a latch and unlatch. If you ever have a latch, which has this little L in the center of the coil, then you must have an unlatch somewhere. If you have a individual coil like I did in the beginning, in the loss of power across this, you see that the output will turn off on its own because the conditions on the left-hand side have changed. So I just wanted to highlight and show those right next to each other here for you. So we feel like we've been feeling long enough until we get to sensor 2. So now sensor 2 is made. So you have both of these conditions, which will turn off that solenoid there, and then we turn on the motor, and we turn on the motor for 10 seconds. So the motor ran for 10 seconds and then opened the last, or the dumping valve. So the dumping valve, again, stayed on until 10 seconds after sensor 1. So we're simulating, so to speak, right now. So sensor 2 is dropped. So the next thing we need to do is the solenoid stays here, and actually put it to 10 seconds just to speed things up. But you can hit Control T here. So now, okay, that solenoid sensor 1 dropped, which means I no longer have product above those 2 switches. So now we're back to our initial start condition. And then, so what I want to do is we're going to fill everything. So we're going to say we're full. And as we're counting, in the event that someone put the manual, all my timers shut off. I'm now in manual mode and everything shut down. And just as a small added, so I know I created this just for simulation purposes, but I have, if I'm filling and not dumping, so filling from either solenoid and not dumping, I am adding 1 to my tank level. Since I don't have a physical, I just have the 2 switches. I don't have a physical reading. I added these in there. And then if I am dumping, I put it back down. I just did those just for a simulation. So one more thing I did want to point out, and I just wanted to go through because we haven't gone through this yet. Let's see, so our motor is running. So you can see the live inputs transition there. So previously, this is all you would see. You just hope everything is working. Now you can add these little glasses. And those didn't exist until version 31. So that's a key feature you definitely want to use or need to use if you have that. All right. So I'm going to turn, Control Z, I'm going to turn everything back off.